So far with derivatives. Let's summarize. We have the limit definitions, right? Okay, what was next? Yeah, the power rule. Okay. What else? Quotient. Okay. Product. Yeah, we've done higher derivatives. Very appropriate for Colorado. Because of the mountains, of course. Okay. What else? We've done some others. Specific derivatives.
Have we?
What else? Yeah, exponentials. Any others? Rates of change, right? So that would be the relationships between those three items. Okay, I think that covers it pretty well. So you can see it starting to load up. Are you studying your memory cards?
Yes.
That's the good answer. If you're not, you're digging yourself a big hole. Big hole. Because today we're going to have 6 more memory cards.
I bet.
6. 6 trig functions, 6 derivatives.
I'm sorry, Ken.
Okay. Okay, let's do this. They fall in this category.
Of exponentials?
They are strictly functions and derivatives that you memorize. Like e to the x is e to the x, right?
Yeah.
You just have to memorize it. Okay? The derivative of sine is, you just have to memorize it. Okay? So, not very difficult. You just have to do the work. Good?
Yeah.
Okay, let's talk about. Do you remember how to graph that function?
No.
Do you remember the unit circle?
No.
It's going to pay dividends. Okay, let's graph sine x. Come on. Oh no.
Down. Are you streaming right now?
Yeah, I am. Dang it! I don't have my grid. That was dumb. Okay, I'm just going to wing it then.
Yeah.
I'm sure there's one in here, but I'm just going to take the time to worry about it. Okay, what does the sine x look like? The graph of sine x, what does it look like? It does look like a sound wave. What does the sound wave look like?
Oscillating.
It would be.
Okay, we'll just make it nice and easy. Got it. Right? That's one period. Remember that vocab word?
Yes.
He does things just to make me mad. But it's not going to work. Okay. The value of sine at 0 is? 0. Okay. The value of sine at 5/2 is? Okay. What about here? What's that point?
Pi 0. Negative 1.
It goes by halves. Half a pi, whole pi, 1.5 pies, and then you get to the good stuff. 2 pies.
That's when you
And then you get fatty.
That's where you do this for.
I do. If I didn't have any fun doing this, I wouldn't be here.
I feel like that is true about every math teacher.
You teach me how to have fun doing math. It's a lot easier when you get good at it. Honestly.
That's never going to happen.
Put some effort in.
Yeah, I think
It's because
all
it's true.
of us
I
were
did not imply that. It's a general statement. I said it's a lot easier when you're good at math. It doesn't mean when you're good at math, it's fun.
Yeah, you said when you get good at math.
You just called a horse.
I did not.
Yes, you did.
Okay,
Not on the video, we have proof.
all right, so let's talk about the derivative
Oh, colors.
of sine x. Okay. At its most basic form, derivative means slope of a tangent line, right? Okay, so what do you think the slope of this tangent line here is?
Zero.
So I'm going to put a point there at 0, right?
Wow.
Okay, what about right there?
0.
Yeah.
Oh, that's good.
We're developing the derivative here. Okay, can you estimate the derivative there?
The negative something.
-2.
Negative something? Okay, we'll put negative something on there.
Yeah.
What do you think this derivative is? Positive something?
Sine, cosine.
Okay, and what about this one?
Oh, it's a coin.
It's a positive something.
Positive something. Does that look very familiar?
Yep.
Oh, same thing.
Bingo, Elise.
Wait, why did you put the?
I just said that.
Oh.
Your mind's just got blown.
Why did you put the dots where you did?
Because I know what the derivative of sine is at those spots.
Because he's good at math.
The derivative of sine is cosine. Amazing. So your unit circle still applies.
So it's
Your purple does not.
Okay. Okay, so this second derivative.
Would it be y equals sin x again?
What did you just say?
Okay, let's see. Let's do it in blue. What's the derivative here? Okay. What about here? Negative something?
Is it just gonna be?
Okay, what about here? And here? Positive something. And here? What function is that? Negative sine x.
Does it just keep flipping like that? Then?
So, are you gonna show us why you do at those points, or you're just gonna say, hey, figure it out?
Figure.
I know that because, okay, the derivative of sine is cosine, right? So, what is the value of cosine at pi over 2? 0.
Probably not.
What's the value of cosine at pi?
What, negative?
-1. Right, so I was placing the dots for you in the right spot on purpose.
Oh,
Guilty.
Yes.
Do you want to do the third derivative?
Yeah, it's negative cosine.
Okay,
Negative cosine.
-1.
0, 1, 0, -1-ish. What graph is that?
So it's a DNA strand.
Yeah, it's a DNA. Claire's just thinking.
Breaking my mind.
Okay, yeah, we're getting a little messy here. But
Yeah, can we stop?
okay, so think about this. What's the derivative of sine? Cosine, but it's negative. Okay, so what's the derivative of negative cosine then?
Positive.
1, 2,
Oh.
3. Guess what? The periodic functions have repeating periodic derivatives.
Well, that makes it simple.
You've just learned the whole cycle of sine x derivatives.
And we just have to memorize it?
Sine equals cosine.
You want, well, if you memorize this cycle, you've got sine and cosine memorized, right? Because cosine's derivative is negative sine. Right?
Yeah.
Okay. There's a very popular AP question.
sine of tangent?
Okay, y is sine x. What is the 96th derivative?
You just divide by 4.
Yeah, what's 96 divided by 4?
It's gonna be y equals sine.
Is it a multiple of 4?
Yes,
It is, so the answer is.
sine x.
Wow.
Is that just a multiple choice question?
It would be a multiple choice question. You will not have a free response where you have to calculate 96 derivatives.
Is
Yeah,
it the
so-
same thing?
We're on the linear question.
Okay, so what's the- 95th
That's what's sine.
derivative?
That's negative.
Cos, minus divisible by.
Because you've got 96 is divisible by 4, right? And you're one less than that, so you're at the third derivative, basically. Right, so. Well, it's all based on 4. Okay, so divide by 4 and then go up 1, 2, 3 or down 1, 2, 3. Okay. So that's how we get the derivative sine and cosine, and that's how they were developed. Okay.
Looky there.
So those 2 memory cards right there, sine and cosine. We'll get them written up. All right. Let's talk about there are some other relationships here. Sine and cosine are always related. Tangent is always related to secant. Okay. The derivative of tangent is secant squared.
Is that at D or what is that?
D over dx. The derivative of tangent.
No, it's just like.
It's the set sign. This is developed out of the quotient rule. How do we use the quotient rule to calculate that?
Yeah, sine equals sine x equals
Yeah.
cosine.
So somebody took sine over cosine, which is tangent, right? And did the quotient rule. And that's what outputs. Okay. If any of you are in BC Calc next year, that you teach that to the class. Somebody does. Okay. Okay, how about
Do we have to teach anything this year?
you get to do your video, possibly. But
We
yeah,
do another video?
calculus. Okay, secant and tangent are related. It's the derivative of secant is close,
Oh.
very close. Okay. Did you see how those two are paired up?
Yeah.
Everything's positive. Okay, those things are patterns that you can see that'll help you memorize this. Okay.
Is it secant the next one of those cosine?
Okay, cotangent, what do you think it's related to? Tan is related to secant, cotangent would be related to
Cosecant.
cosecant. And it's also squared. Okay. Jordan, I hope you're taking notes on math on your computer. Okay. So, what might the derivative of cosecant be? Oh, that is ugly.
Or
We're just gonna
Would it be cos?
cosecant.
That's
Yes.
cosecant.
Forgot something.
X.
Square.
That's negative.
Oh, it's a negative. Okay.
So we have negative.
Negative cosecant x and tangent x.
See how those two follow the same pattern?
Yes.
Yeah, they do. So cosecant and cotangent are related. The derivatives are negative. Okay. And these two follow the same pattern on both sides. Okay. So there are your 6 memorized derivatives.
So do we need to put down no code?
We will, yeah.
It's Wednesday. Mm-hmm. Forgot it was Wednesday. Next Wednesday, we're gonna call
Let's do one more problem and we'll be good. We're almost done. Right?
And then we have study sessions.
The equation
No.
of the tangent line, of the tangent line to, which one do you want to do?
A medium.
Why not?
She said
X cosine X?
Okay.
Pi over 2. I put that one in there so you'd see a product rule with a trigonometric derivative.
Great.
Okay, so I automatically think, write the formula down so I have it memorized. Right? That one we should have memorized.
I have
by now.
that. That's for sure.
So what do I need?
Slow.
F prime of X and,
A point.
A Y value and an X value.
right? You gotta plug those in. So what is at pi over 2? Cosine pi over 2. Yeah. 0. We have our point, right?
Yep.
Okay. Now the derivative. Are you following? Because I'm going fast.
Yeah.
2 people are following. Fantastic.
I got you. Don't worry about it.
Derivative.
Don't worry about it.
I need to worry about you. Trust me. Used to be up at night.
You are just like.
Derivative? Anybody?
One multiplied by something or a negative sign.
What rule is it? Product rule. You can't just do 1 times sine x.
Nope.
You have to use the product rule. So, derive, copy, plus, copy, and what's the derivative cosine?
Negative
Sine. Now plug pi over 2 in,
Oh, goodness.
and you got your slope. What's sine at pi over 2? 1. There's your slope, negative pi over 2. Eight. For checking my math, of course, because sometimes it's blundered in. Do you see how often we have to do that? Okay, get used to it. I hope you're used to it by now. I hope you're good at it. There's another one of those on the quiz retake tomorrow.
Yay.
Okay, it's polynomial, just like the original retake. Questions? We'll get cards made soon, so you can start memorizing those for your tests. Okay? There you go. And again, you will be, everything we talked about on the first slide, power rule, product rule, quotient rule, you're gonna be doing all that, practicing that with trig derivatives, okay? So things are starting to compound. If you are having issues, please come get help.
And then we got that.
Yep. Tomorrow we be moving on to the chain rule
I thought we had a test tomorrow.
and a quiz. Oh, wrong one.